So circuit questions with the answer keys. At the end of each question, you will find the answers as well. So we did the first three questions. Now question 4. Remember the I and V graph. What slope represent? The slope represent reciprocal of the resistance. So example, as you see, the two graphs are there. One is for lamp, another one is for resistor. So if the current is on y-axis and voltage on x-axis, what slope represent? The slope represent reciprocal of the resistance. So what happened for a lamp? What happened to the slope for a lamp? Is it increasing?
Decreases.
So slope is decreasing. You can see the curve, the angle with x-axis is decreasing. So if the slope is decreasing, what happened to resistance? It means the resistance is increasing. So for a lamp, resistance is increasing. But what about the fixed resistor? The slope of a fixed resistor does not change, or a slope is constant. So if a slope is constant, it means the resistance is also constant, or resistance of this component is not changing. So for fixed resistor or a resistor, the slope is constant. So resistance is constant. Whereas for a lamp, what happened? The slope is decreasing. As the slope is decreasing, so the resistance is also increasing. Opposite will happen. Slope and resistance for IV graphs are inversely proportional to each other. So the potential difference applied across the resistor increase. Tick the box that indicates that effect on the resistance of a resistor. What happened to resistance of the resistor? You can use screen annotation to tick. What happened to resistance of a resistor from this graph and resistance of the lamp? Because it's a straight line, so its resistance is not changing. And for the filament or a lamp, what happened? Because the slope is decreasing, so its resistance is increasing. And what if there is another component which the slope is increasing? So if the slope is increasing, resistance will decrease, and that will be the semiconductor or thermistor. The next part, the potential across the lamp is 6. We have to calculate its resistance. How to work out the resistance? Resistance is actually a ratio between the voltage and current. So voltage divided by current, we get the resistance. We have the voltage, but we don't have the current. So for current, we have to use this graph. So when the voltage is 6, what we do, we draw a line, and you have to show these. Whenever you're using the graph for any kind of values, you should show this on the graph. So we need the resistance of the lamp. So if we need the resistance of the lamp, what we'll do? We will at when the voltage is 6. So when the voltage is 6, we'll draw a line when voltage is 6 and find what is the current. So on x-axis, like on y-axis, each 10 boxes equals to 2. So each is 0.2. So this will be 4.2, this will be 4.4. So current is 4.4 and the voltage is 6. We need the resistance. Resistance is the ratio between voltage and current. So voltage is 6 and the current is 4.4. 6 divided by 4.4. What is the answer?
1.36.
So 1.36, and the unit of the resistance is ohm. You can write OHM, that is fine, or you can use a Greek alphabet, the symbol omega, instead of writing ohms. The next question, the lamps and the resistor. The lamps and the resistors are connected in parallel to 6 volt. So if two components are connected in parallel, the total current, we need the current from the supply. So there is a lamp and there is a resistor, and both are connected to a 6 volt supply. So means because they are in parallel, the voltage of the supply is same as the voltage across each component. What we need the total current from the supply. So the total current from the supply will be equal to sum of the current in each component. Like what current flow through the lamp and what current flow through the resistor. When we sum them, we'll know how much current entered from the supply. We already know that there was 4.4 ampere We already know that there was a 4.4 ampere current from in the filament lamp. Using the graph, we'll find how much current is there in the resistor, and then we sum to work out what is the total current in the from the battery. So using the graph, so we already know that when the voltage is 6, because they are connected in parallel, so they will have the same voltage. So when voltage was 6, the current in the filament was 4.4. And when the voltage is 6, what is the current in the resistor? That is about 4. And both are connected in parallel. So there is a lamp. The lamp was having 4.4 ampere, and there is a fixed resistor. The fixed resistor was receiving 4 ampere. The question is, how much current flow from the supply? So what will be the current from the supply? That the current from the supply is actually divided between the lamp and resistor which are in parallel. So the total current will be equal to sum of these current in the branches, which is 4.4 plus 4, that's equal to 8.4 ampere. So again, as I mentioned, whenever you are using a graph, you have to show, you have to draw these lines on the graph. That how you worked out. You just not directly use the graph and just say the answer. You have to show that. So the current will be 4 plus 4.4, which is equals to 8.4. Now lamp and resistors are connected in series to another power supply. The current is 4 ampere. Calculate the potential across the lamp and the resistor. So how we can work out potential means we need a voltage. Again, you will have to use the graph here, like there is a lamp and a fixed resistor, but this time both are connected in series with each other. So when they're connected in series, we need the potential, the total voltage across both of them. So if this voltage is V1, this voltage is V2, the total voltage will be equal to V1 plus V2. So when the current is 4 ampere, because they're in series, the characteristic of a series circuit that the current is always same. So if this 4 ampere, same 4 ampere will flow through each component and return back. So what we'll do, again, we will use the graph and we will find how much current is, like we will find for 4 ampere current, what is the voltage across each of them, and then simply sum them. So when the current is 4 ampere in the lamp, what is the voltage across the lamp? So this is the voltage across the lamp. And what is the voltage across the resistor? This will be voltage across the resistor. So this is approximately like each box is representing on x-axis also 4.2, 4.4, 4.6, 4.8. So this is 4.8 volts and this one is 6 volt. So there is a lamp and there is a fixed resistor. Both are connected in series. Across the lamp, the voltage was 4.8. Across the fixed resistor, the voltage was 6. The question is, what is the total voltage in this combination? So as they are connected in series, the total voltage will be just sum. So it will be 4.8 plus 6. That's equal to 10.8 volts. Is it clear, this one?
Yes, sir, clear.
So when components are connected in series, the total voltage will be the sum. When components are connected in parallel, the voltage will be equal and the current will divide. So this was a question from the circuits, electrical circuits.